Hey, photosynthesis.
Cell respiration. Yeah.
We gonna tell you how energy is made, Mr. K.
So it all starts off with photosynthesis. Two main stages, light and dark. You put them together and you get glucose. In the light reaction, we're in the thylakoid, the membrane. That's right. Then we go to P2, where H2O is gonna split from light energy. O2 goes bye-bye, H plus is head inside, electrons on to the next one. These H pluses are grooved across the membrane. Now we got a real big gradient here. Electrons off to P700. They're gonna take in energy. Now we have re-excited electrons. NADP plus comes through. Electrons, add the H. Don't forget about the gradient. We still gotta make some ATP. The H pluses come through the synthase, given energy to make ADP and P come together. That NADPH is on its way to the dark reaction.
Here comes number 2. Calvin is coming through. No, it doesn't need light energy. This time we're in the stroma, using 3CO2 and 3RUBP, aka call it 5C. Together they will form 6G3P. Hold on, let's not go too fast. Rubisco, the enzyme's gonna help us. Fuse them together and you have 3,6C, turning into 6PGA. A 3 carbon with the phosphate, ATP returns. Gives PGA another phosphate, NADPH, it's your turn. Given the compound your electrons, now we have our final product. Sadly, we can only take one. If you want to keep the cycle going, we'll just have to return the other 5. RUBP is reformed from the G3P. We have our building block now for our glucose. Just a few more cycles. Now we got what we're looking for.
Now we're on cell respiration. We start things off with glycolysis. ATP turns to ADP twice. C6 is given 2 Ps. This allows it to break up into 2, PC3. 2 NAD plus comes along, captures the excited electrons. Now we got 2 NADH. These go to the ETC. 1 phosphate is added to each compound naturally. Enzymatic reactions remove the 4 Ps to give us 2,3C. In this reaction, 4 ATP are made. We now have 2 pyruvate. These are going to go to the cytoplasm.
Here we're at the grooming phase. Once he is cut off of the 3C, is let off as CO2. Coenzyme A comes in, attaches to give us acetyl-CoA. The extra energy is taken away. 2 NAD plus converts into 2 NADH. Now we have a substance that can fit through the mitomembrane. Remember, we have 2 pyruvates, which makes this process duplicate. We in the matrix now. The CoA leaves now. Prep cycle begins and the cycle starts. The 2C now joins with the 4C. Together they create a citrate. A carbon leaves as a CO2. NAD plus turns into a NADH. This process just stated happens again, which leaves you with a 4C. These atoms are rearranged. ADP to ATP. FAD2 plus captures energy. After this, you're back with a 4C. All those NADH and FADH2 are gone to the ETC. This process purpose was to get energy. Let's go to the ETC.
Now we arrive at the intermitomembrane membrane where there are many ETCs. NADH drops off its electrons at the first protein. These electrons pull the H pluses from the matrix to the IM space. FADH2 does the same thing at the next protein. This creates an H plus gradient. At the ATP synthase, H pluses fuse across the membrane, giving the energy to fuse ADP and P into ATP. The H plus at the matrix come together with oxygen, which forms H2O. As you can see, these processes are very alike. The products of photosynthesis are used in respiration. The same thing works vice versa. Photosynthesis relies on respiration. Together they create glucose, then ATP.